So returning now to our example, let's do the SIRs for the first iteration using the power levels that we just changed to. So we know that the noise in the receivers are their values that we had before, and here are the transmit powers that we computed before: 1.4, 1.5, and 2.68. So now the transmit powers aren't the same at each of them anymore, so we're not going to have the 2 milliwatts everywhere. They're going to be different values now, and we'll see how that plays out. So we can start with our equation for measured SIR at link A, and if we start off, remember again, we have direct times the transmit power, so 0.9 times 1.4, that's the signal, and then the interference is 0.1, not times 1.4, but times 1.5, because that's B's transmit power right now. 0.1 times 1.5, 0, plus 0.2 times 2.68, and then we add 0.1, which is the noise in the receiver. And I'm not going to write the milliwatts out because we saw before how they cancel out. So then we do this, we're going to get 1.26 divided by 0.786, which is going to give us 1.60. So now we can move on to B. We saw the direct is 0.8 times 1.5. The indirect from A is 0.1. You multiply that by 1.4. Plus the indirect from C, which is 0.1. You multiply that by 2.68. And then we add 0.2 onto that. And if we do that out, we get 1.20 divided by 0.608, which is 1.97. Now let's move on to C. The direct transmit power is 0.9 times the gain, which is 2.68, divided by 0.2, which is the indirect from A, times A's transmit, 1.40, plus the indirect from B, which is 0.2, times 1.50, that transmit, plus the noise in the receiver, which is 0.3. And we get 2.412 divided by 0.880, which is 2.75.